In Activity 9, How Do Bulbs Work?, students investigate how the light bulb is constructed. Students first examine two different light bulbs and then use a circuit to determine how a light bulb is put together. Finally, students discover how a light bulb works. You will need the following materials from the kit: Activity Sheet 9, D-cell batteries, battery holders, number 41 flashlight bulbs, number 48 flashlight bulbs, electrical clips, magnifiers, and 15-centimeter insulated copper wire pieces. To prepare for the activity, make a copy of Activity Sheet 9 for each student. Each team of 2 will need one battery holder, 2 electrical clips, one number 41 bulb, one number 48 bulb, one magnifier, and 2 pieces of copper wire. To begin the activity, distribute a copy of Activity Sheet 9 to each student and a magnifier, one number 41 bulb, and one number 48 bulb to each team of 2. Have students use their magnifiers to examine the bulbs. Then instruct them to draw the insides of the bulbs and write a short explanation of what they see on their activity sheets. When their observations are complete, discuss the characteristics of both bulbs. Students should describe the wire inside both bulbs as thin, coiled, and tied to 2 thicker wire supports. Ask students, what purpose do you think the filament has in a light bulb? Students may recall that the filament was the part of the bulb that glowed when electric current passed through it. Then ask, why doesn't the filament burn up like other things do when they get so hot that they glow? Students may suggest that the filament is made of a special material. Explain that the filament is made from tungsten, a metal that can reach temperatures of over 2,200 degrees Celsius without melting. Next, distribute the materials to each team. Collect the number 41 bulbs, as students will only test the number 48 bulbs. Instruct students to construct the circuits, record their results, and complete all but the last question on their activity sheets. When students have finished, bring their attention to the 3 circuits on the activity sheet. Ask in which circuit were the wires arranged on the bulb so that the bulb glowed. Students should have observed that the bulb glowed in circuit C. Then ask, where does the electric current have to go inside the bulb in order for the bulb to glow? Help students understand that the current has to go to and across the filament. Encourage them to think about the purpose of the 2 thicker wire supports: to support the filament and electrically connect the filament to the base of the bulb at 2 different spots. Continue the class discussion by asking, how do the thick wires allow the filament to be electrically connected to the outside of the bulb? If necessary, point out the thick support wire contacts the metal case on the side of the bulb, and the other wire contacts the tip at the base. Draw the inside of a light bulb and trace the path of electric current through the bulb, from one support wire of either the tip or the metal case, through the filament to the other support wire and back out through the tip or the case. Then, have students draw a similar diagram of the inside of a bulb on the back of their activity sheets. Ask students, what would happen if the filament were to break? Students should respond that if the filament broke, the circuit would open, the current would stop flowing, and the bulb would go out. Then ask, what would happen if one or both of the 2 support wires were to break? Help students realize that if the support wires broke, the circuit would open, the current would stop flowing, and the bulb would go out. Encourage students to think about how a light bulb produces light. Guide the class to understand that a current from an energy source, such as a battery, flows through the support wires and across the filament, causing the filament to glow and give off light. Finally, inform students in the next activity, Making a Bulb, they will construct and test a light bulb. To conclude the activity, have students return the magnifiers, batteries, battery holders, electrical clips, bulbs, and wires to the kit. For science background, reinforcement activities, curriculum connections, and information about the Delta Science Reader, please consult your DSM Teacher's Guide.